Alright, so now we are going to do 15b. So 15b, we're looking at the function g of x is equal to the natural log of x squared plus 1. It's worth noting first where this is defined. When I see the natural log, I get a little bit worried because what if I'm going to be plugging something inside of it that is negative? However, x squared plus 1 is always positive, so therefore the natural log of x squared plus 1 is also, well, always going to be defined. In fact, since x squared plus 1 is greater than or equal to 1, it's always non-negative. Anyways, so let's take its derivative. G prime of x is equal to 2x over x squared plus 1. This is just the logarithmic derivative. And I really have to say, where is this undefined? Where is this equal to 0? Because those are places where I might run into minimums and maximums, and also places where the first derivative might change. But the bottom, again, is always greater than or equal to 1, so it's never 0. I'm never divided by 0. I don't have to worry about that, so just set it equal to 0. If a fraction is equal to 0, then its numerator is equal to 0, and 2x is equal to 0 when x is equal to 0. So this means that I just have to analyze increasing and decreasing on the two intervals from negative infinity to 0 and from 0 to infinity. I'll choose, say, the number negative 1 from here and 1 from here. G prime of negative 1 is negative 2 over negative 1 squared plus 1, which is 1 plus 1, so this is negative 1, which is negative, so that means it's decreasing on this interval. Whereas g prime of 1 is equal to 2 over 1 plus 1, which is equal to 1, which is positive, so it's increasing on this interval. This also implies, from the first derivative test, that since the function is decreasing up until 0 and then it's increasing, or equivalently that the first derivative is negative until 0, then it's positive, we have a local minimum at 0. Fantastic. So now let's also apply the second derivative test. If I take g double prime of x, using the quotient rule, I get the derivative at the top, which is 2, times the bottom, which is x squared plus 1, minus the top, which is 2x, times the derivative of the bottom, which is 2x. And this is all over the bottom squared. The bottom is x squared plus 1 squared. And this is equal to 2x squared plus 2 minus 4x squared over x squared plus 1 squared. And this is equal to 2 minus 2x squared over x squared plus 1 squared. If I plug in 0 into here, I get 2 over 1 squared. I just get 2, which is positive, and by the second derivative test, this means we have a local minimum. Now, in terms of concavity, we need to set the second derivative equal to 0, and if I set the second derivative equal to 0, then the top has to be equal to 0. And 2 minus 2x squared is equal to 0. There are a variety of ways to solve this. Why don't I add 2x squared to both sides, so I get 2 is equal to 2x squared. Divide both sides by 2, I get 1 is equal to x squared. Taking square roots, I get x is equal to plus or minus 1. Great. So let me select all this, and or let me delete that. So again, just to write down the information that we had, g double prime of x is equal to 2 minus 2x over x squared plus 1 squared, and I know it's equal to 0 at x equal to plus or minus 1. So that means that to figure out where this interval, or where the function is concave up and concave down, I look at the following three intervals: from negative infinity to negative 1, from negative 1 to 1, and from 1 to infinity. Fantastic. I will choose the point negative 2 from this interval, the point 0 from this interval, and the point 2 from this interval to plug into g double prime to figure out concavity. G double prime of negative 2 is 2 minus 2 times negative 2 over that was 2x squared, sorry, negative 2 squared over negative 2 squared plus 1 squared, which is 2 minus negative 2 squared is 8, so times 2, negative 2 squared is 4, so times 2 is 8. So it's that over, this is 4 plus 1 squared, that's 25. This is negative 6 over 25, which is less than 0. So that means that it's concave down on that first interval. We already saw that g double prime of 0 is equal to, what was it equal to? 2, which is positive. So that means it's concave up on this middle interval. And you can check that g double prime of 2 is also equal to negative 6 over 25, which is less than 0. And so that means it's concave down on that final interval. Fantastic.